What specific problem does Reddio aim to solve regarding the performance bottlenecks in blockchain systems, particularly in the context of Ethereum's execution model?
Reddio aims to solve the performance bottlenecks in blockchain systems by addressing both computational and storage inefficiencies inherent in Ethereum's execution model. Specifically, Ethereum's sequential transaction execution limits throughput, as transactions are processed one after another, even when they are independent. This sequential model, combined with the high I/O overhead from the Merkle-Patricia tree, MPT, used for state management, contributes to significant execution delays, accounting for approximately 70% of the overhead. Reddio introduces a batch-based parallel transaction execution framework that optimizes execution across both the transaction processing layer and the state storage layer, allowing for efficient scheduling of independent transactions while minimizing state conflicts. Additionally, Reddio implements an asynchronous state database that decouples execution from storage operations, thereby reducing latency and maximizing throughput.
How does the proposed method, Reddio, work? Illustrate the workflow step by step, detailing how transactions are processed and how the storage layer is involved.
Reddio operates through a batch-based parallel transaction execution framework that optimizes both transaction processing and storage operations. The workflow begins with the coordinator fetching a batch of transactions, which are then assigned to worker threads for concurrent execution on separate copies of the global state database. Each transaction records its read and write sets during execution, and if any transaction reads stale data due to overlapping state access, it is aborted and re-executed in a future batch. After executing the transactions, the coordinator merges the successful state updates into a new state database. To enhance storage efficiency, Reddio employs an asynchronous state database that decouples execution from storage operations, allowing state updates to be processed without blocking transaction execution. This is achieved through techniques such as direct state reading, asynchronous node retrieval, and a pipelined workflow, which collectively minimize I/O overhead and maximize throughput by ensuring that state access does not become a bottleneck.
Can you provide a simple yet illustrative example that demonstrates Reddio's batch-based parallel transaction execution and how it effectively reduces state access bottlenecks during execution?
Reddio's batch-based parallel transaction execution can be illustrated with a scenario involving three independent transactions, T1, T2, and T3, that each update different accounts in the blockchain. In a traditional sequential execution model, these transactions would be processed one after the other, leading to significant delays due to the sequential state access required by the Merkle-Patricia tree, MPT. However, Reddio groups these transactions into a batch and executes them in parallel on separate copies of the global state database. During execution, Reddio employs direct state reading, allowing the Ethereum virtual machine, EVM, to access state values directly from a key value database, bypassing the MPT traversal, which reduces read latency. Additionally, Reddio's asynchronous node retrieval allows necessary tree nodes to be fetched in parallel with transaction execution, further mitigating I/O bottlenecks. By decoupling execution from storage operations through a pipelined workflow, Reddio ensures that while transactions are being executed, state updates can be processed asynchronously, thus maximizing throughput and minimizing state access delays. This approach effectively enhances overall system efficiency and scalability, demonstrating Reddio's capability to address state access bottlenecks during execution.
What are the theoretical or practical benefits of implementing Reddio compared to existing blockchain transaction execution methods, particularly in terms of throughput and latency?
Implementing Reddio offers significant theoretical and practical benefits over existing blockchain transaction execution methods, particularly in terms of throughput and latency. Reddio employs a batch-based parallel execution framework that optimizes both transaction processing and state storage, allowing for efficient scheduling of independent transactions while minimizing state conflicts. This design enhances throughput by enabling parallel execution of transactions, which can exceed 5,000 transactions per second, TPS, compared to Ethereum's limitation of around 30 TPS. Additionally, Reddio introduces an asynchronous state database that decouples execution from storage operations, significantly reducing read latency and I/O amplification associated with traditional Merkle-Patricia tree (MPT) operations. By integrating techniques such as direct state reading, asynchronous node retrieval, and a pipelined workflow, Reddio effectively mitigates storage bottlenecks, leading to lower transaction confirmation times and improved overall system efficiency.
How is Reddio validated or tested? Discuss the experimental design, datasets used, and performance metrics that demonstrate the effectiveness of Reddio.
The paper does not provide explicit details on the experimental design, datasets used, or performance metrics for validating or testing Reddio. However, it emphasizes the importance of ensuring correctness through deterministic serializability, which is validated by proving that if a transaction reads a stale state value, it will eventually be aborted and re-executed. The correctness of Reddio's protocol is established through a formal proof that demonstrates its parallel execution produces the same results as serial execution, ensuring all nodes reach a consistent state. Additionally, the paper discusses the integration of optimizations like direct state reading and asynchronous node retrieval, which are likely evaluated through performance analysis, although specific metrics or datasets are not detailed. Overall, while the paper outlines the theoretical framework and correctness guarantees, it lacks concrete experimental validation information.
What are the limitations or drawbacks of Reddio, particularly in terms of scalability or complexity in its implementation?
Reddio, while addressing significant performance bottlenecks in blockchain systems, has limitations that could impact its scalability and complexity. Firstly, the asynchronous state database introduces challenges such as stale data access and unpredictable write bursts, which can overwhelm the storage backend, potentially leading to inconsistencies during high transaction volumes. Additionally, the batch-based optimistic parallel execution model, while improving throughput, may still face issues with implicit conflicts among transactions that invoke the same smart contract, necessitating additional coordination and potentially leading to aborts and retries. Furthermore, the complexity of determining commit points for nodes in the account tree adds another layer of intricacy, as it requires estimating the likelihood of modifications by remaining transactions, which can be computationally intensive. Lastly, the reliance on a pipelined workflow for state management may introduce overhead, as premature hashing of frequently modified nodes could lead to redundant computations, thereby complicating the implementation and potentially limiting scalability.